a few computational thinking activities in this video. And while this isn't a live session, I'm going to encourage you to kind of play along and maybe pause, do your own thinking, and come up with your own answers before I continue on through the video. So the first activity that we're going to look at is one that I believe many of you are familiar with because it is something that shows up in the elementary math curriculum, and that is a game called Which One Doesn't Belong? So this is a number game, and the simple task is the name of the game. Decide which number doesn't belong. And so when you do this with kids and with adults, you'll find there are so many different answers that people have. So for example, many students might say 16 because it's even. Some might say 9 because the digits in each box of the others add up to 7. Some say 43 because it's not a perfect square. 9, 16, and 25 are all perfect squares. Those are just a few answers. There are lots of other ones here. And what this activity does is it gets kids sharing and talking and explaining their thinking, but it also gets them comfortable with there being multiple right answers and really no wrong answer as long as they can explain their thinking. So you can also move this activity away from math, and you can use images or logos or shapes and all sorts of different things. And I like this one because so many of our students may not know what BBC is, and they may not know what that PBS icon is, but they still will have excellent answers to this question of which one doesn't belong. So as you can imagine, many would say NBC because it's colorful, or the logo in the bottom right because it is a circle and it doesn't have any letters, or those of us who are familiar with a circle representing PBS might say ESPN because it's 4 letters. And there's so many different ways that kids think about these. If you have never seen this game before, or if you're not familiar with non-math examples, I would really encourage you to go to wodb.ca, which stands for Which One Doesn't Belong. And if you go to this website, it is filled with rich examples. So at the top, we have shapes, numbers, graphs, and complete sets. And I'm just going to click shapes here. And while you may not use one of these directly, you might get inspired because there's so many different ways that people play which one doesn't belong. And so we have maps here, and you saw an image of cookies above, and tangrams and algebra tiles. We have pictures and drawings and street signs. So this is a really fun music notes. I like this one a lot. So many ways to do this game of which one doesn't belong that go beyond math. So this is a cool one. So if we think about computational thinking, which concepts and approaches did you see or feel when doing that activity? So these are my responses, and again, kind of like the activity, there's no right or wrong answer, but I do see patterns and pattern recognition being a big part of this activity, as well as abstraction and removing unnecessary detail to really see those patterns. There's also communication when students are explaining their thinking to others, which is a key part of collaborating. This next game is called, I've heard it called 20 questions, but I think there are many names for it. And so in playing this game, I as the teacher would select one of these images or one of these organisms, and I would not tell the students which one I would selected. And it is their collective task as a group to ask yes or no questions to figure out which one I have selected. So when you start with students, you can imagine the first student hand flies in the air and says, "Is it a dolphin?" And if the answer is no, they really haven't narrowed it down very much. And the students start to figure that out, and then they'll start to say, is it an animal? Is it a mammal? And if the answer is yes or no, well, then it really eliminates a lot more. So for example, if a student says, "Is it a mammal?" and I say yes, well, then they can eliminate at least 4 of those other options. So when playing this game, you'll start to see creativity flourish, which is fun too, just the different ways that people's minds work. So I'll never forget the first time someone said, Are there more than 4 letters in the word? And I had always had students focus on the pictures, but this person was really looking at the words. And then after we had narrowed it down, a student said, does the word start with an F? And so really cool to see the different ways that people think about this. And then also you'll have the beginning of the game where students are really not quite used to the idea that depending on the answer, yes or no, in their minds, they have to eliminate certain answers. And so you see them get better and better and better at this. And I play this game repetitively. And over the course of just a few minutes, they improve immensely in how they're able to do this. So the goal is each time we play, we want to get the number of questions it takes for them to guess the correct animal or organism down. And by the time we're done, students can often do it in about 4 to 3 questions consistently each time. So what concepts and approaches of computational thinking do you see in that activity? Well, I believe there's some logic. There's analyzing how certain questions were successful or unsuccessful. The algorithm is huge here when students are understanding that if my answer is no, which ones are now eliminated from the possibility. There also have students really starting to think through, depending on their age, what kind of questions might eliminate the most possible options. Of course, there's patterns and abstraction as they're looking for similarities. And then I believe there's debugging here as they're really thinking, okay, how can we make it better? Which questions are better than others? Which questions didn't really help us? The last one I want to think about is the redesign the save icon activity that we did earlier as an introduction this morning. What computational thinking approaches and concepts were present in that activity? Well, I believe that there is decomposition of really thinking about why that icon is not interpretable by some students and breaking that down. There's abstraction in removing unnecessary detail. That's kind of the key for any logo design. There is predicting and analyzing how someone might interact with that logo. There's tinkering and creating, persevering depending on someone's experience. They may really have to persevere through this activity, and depending how the activity is run, there can be collaboration. The last resource I'll just share is this website stem.family, and I simply Googled computational thinking activities for elementary students, and this was a great resource that I found. And what it does is has a super long list of computational thinking activities, and I just am sharing the top 3 with you here. But I liked how it really shows that computational thinking is everywhere. So they have an activity where you have to organize clean dishes using computational thinking, and there's another one where you have to evaluate which line will be the fastest at the supermarket using computational thinking. And then the last one, you create an algorithm to clean your room. And so these are just kind of fun ways to get kids thinking about how computational thinking really makes us better thinkers in everything that we're doing, not just when we're writing programs or creating code.